In this video, we are going to explore the concept of the mole. In chemistry, there is a way to count for atomic particles, or in other words, chemical concepts. The mole is a way to count particles like atoms, molecules, ions, and grouping them into a single number. The mole is kind of like the idea of having defined 12 objects as a dozen. Well, in chemistry, when we group atoms, molecules, or ions into a single number, that is known as Avogadro's number. In Avogadro's number, that single number that defines these atoms, molecules, or ions is known as 6.022 times 10 to the power 23rd. So what that means is that in chemistry, when we have a mole of anything, of an element or a compound, this is going to equal 6.022 times 10 to the 23rd particles. It could be molecules or it could be atoms. In figure 4.1, we see different beakers that are containing specifically 1 mole of substances. And you can see gradually how, in this case, these solids look like in height a little bit different, but it's all representing 1 mole of a substance. When we have the concept of moles, moles are allowing us to actually convert from this given unit into atoms or molecules and vice versa. From atoms and molecules, we can convert to moles. We are always going to be using Avogadro's numbers, meaning 6.022. Let me add the extra 2 times 10 to the 23rd as our conversion factor. Let's now do some practice problems to see how we can use Avogadro's number in order to convert from moles to atoms or molecules. Let's look at this practice problem. The practice problem reads, how many molecules are present in 1.75 moles of carbon dioxide? You can see on the left side of the slide, that is just the solid form of carbon dioxide, which we know as dry ice. In this problem, since I am given 1.75 moles of CO2, and I need to find molecules of CO2. If I go back to the flow chart that I just showed you, since I am given moles, the arrow that takes me to molecules is going to be multiplication by Avogadro's number. And that's exactly what we're going to do. We are going to use dimensional analysis in order to set up the problem. 1.75 moles of CO2. In the bottom, since I know that my equality establishes that 1 mole of CO2 equals 6.022 times 10 to the 23rd molecules. MOLEC is my shorthand for molecules of CO2. Then I can take this equality and convert it into a fraction and find the correct result. Since I want to cancel the unit of moles, then I know that in the bottom of this fraction, I'm going to write 1 mole of CO2. On the top, I'm going to write what 1 mole of CO2 equals to, which is 6.022 times 10 to the 23rd molecules of CO2. So in your calculator, what you have to do is multiply 1.75 times 6.022 times 10 to the 23rd. The calculator display shows 1.05385 times 10 to the 24. But in this problem, since we have 3 sig figs given, we need to round it to 3 sig figs. So the result is 1.05 times 10 to the 24 molecules of CO2 are present. When I show my cancellation of units, mole of CO2 cancels with mole of CO2. So this is my final answer. Let's just do another example in which now we start with molecules, but we need to find moles. In this problem, it reads, how many moles of water, H2O, contain 2.60 times 10 to the 23rd molecules of water? So in this problem, if I go back to the flowchart on slide 13, I start here, molecules, and I'm trying to convert to moles. The arrow that takes me there is going to be this one, which means that I'm going to divide by Avogadro's number. So I set up my problem. 2.60 times 10 to the 23rd. Since I know that this is the equality for Avogadro's number, and we're just going to, let me write the correct units. This is molecules of water. Let me now write my equality as a fraction. So since I'm dividing by Avogadro's number, I'm going to write in the bottom 6.022 times 10 to the 23rd molecules of water. And on the top, 1 mole of water. The units of molecules of water cancel. So when I take and plug in my calculator 2.60 times 10 to the 23rd, and I divide it by 6.022 times 10 to the 23rd, I see that my calculator display shows me 0.43175 and then a series of digits. Since I start with 3 sig figs, I need to round my answer to 3 significant figures, and my final answer is 0.432 moles of H2O, and it is a 2 at the end because of rounding rules. And that's how many moles of water we have in 2.60 times 10 to the 23rd molecules of water.